This is our rotation about X. Okay. Yes. Because C is the furthest distance away relative to the centroid. Why? Because the furthest distance away from the centroid, your stresses will be the highest. Remember the formula that we derived from? Remember this? I know we did not copy this. The maximum stress is down here is where C appear. C is the furthest distance away from the where? From the centroid. Okay. Yeah, that's the problem for us not deriving, right? Yes. You have to divide by 2. This is because this is the point of wrong software. No, correct. This is the point of interest. This entire distance is 120. You'd have to divide by 2. From here to here is 60. No, don't be. Better clarify things now. Term test, you made a mistake. I come after you. Yes? Yes. You again. What is the question? That is the problem. I'm teaching this course and this chapter. So what should C be? Yeah. What should C be? Yeah, you. Not you, the one behind you. The furthest distance from the centroid. Yeah. Not relative to the what? Applied force. Why? Right? You thought it's relative to the applied force. Am I right or am I wrong?
Yeah, these were the same.
No. My fault in this one. Okay, my fault. We have to get this clear. If this is the distance of the applied load, we have this distance E, and this point is of interest. Yes or no? The position is not relative to the what? The position is not this distance. Not relative to the load. It's relative to the what? To the centroid. Why? If you look at bending moment, formula is equal to M Y over I. Y is relative to what? Centroid. Are we clear? Now, this is just the beginning. When we do 3D loading, you will go bonkers. Get this right now. Good question. Okay. So it is based on what? The Y is based on the centroid, which is the geometry of the cross-sectional area. It's not relative to the platform. Are we clear? Okay. Again, a lot of students make the same one. Make the same mistake. Okay. Be good. I need to talk to Dr. Koshi. Right. So now the next question is this. Eugene say is relative to the cross-sectional area. That is why we have to determine the what? Eccentric distance relative to the what? Relative to the What? The point or the centroid? Centroid. The centric distance is relative to the what? To the centroid and relative to the what? The point of interest. Then is this C that compensate for the distance relative to the what? Centroid. Does that make sense now? Okay, good. So from here, I think I need to take some drugs to calm down. So relative to this point of view, we need to find our E now. Okay, we need to find our E now. So when that's the case, we are going to take moment about X. Okay. So moment about X, everything that's going anti-clockwise will be positive. So from here, we have what? 130 is going what? Anti-clockwise. So 130 times 10 to the power 3, and then multiply by a distance of what? 0.12. And then the next one will be minus 50 times 10 to the power 3 multiplied by a distance of 0.08. Why? Because relative to the centroid, one is going clockwise, the other one is going counterclockwise. So this will be equal to 130 power 3 times by 0.12 minus 50 power 3 times by 0.08. So you have 1,600 Newton meter. So we know moment about X is equal to PZ multiplied by E. Okay, so PZ is equal, we calculated PZ is 180 times 10 to the power 3 E, and then MZ is 1,600. So therefore E will be equal to 1,600 divided by 180 power 3 is equal to 64.444 times 10 to the power minus 3 meters. Okay. So now looking back at our equation, we have everything now. Okay. So we have everything now. We have E, we have C, we have everything. So what I request from you is this. I'm going to put down the formula. Oh, you guys are still copying. Sorry, I will not rush. And I want you to take out your calculator. I don't trust all of you not to press your calculator. Seriously. I don't trust you at all. Okay. A lot of times you'll get the numbers right. Then when punch into calculator, answer come out wrong. Then after that, you're challenging me. Eugene, I should get full marks for this. Okay. So I want you to use your calculator. Okay. I'm not treating you like high school kids, but I want to know. So now we have what? This will be equal to 180 times 10 to the power 3. Cross-sectional area is 3 times 10 to the power minus 3. This will be 1 plus by E is equal to what? 64.444 times 10 to the power minus 3. C is equal to 0.06. Radius will be equal to 47. Is it 47? 47.958. So it's 47.958 times 10 to the power minus 3. The whole thing squared. Then the whole thing again goes through a bracket. Then we have secant. Then secant we have pi over 2 multiplied by, all these are together, yeah? Square root of P, which is equal to 180 times 10 to the power 3 divide by 772.122 times 10 to the power 3, close bracket. Okay. What is the second value? Come on, someone press your calculator and tell me. Yes, ma'am. Hey? 0.11, yeah? Thank you. What do you get? Yes. Include the square root everything. So this term over here are together. What do you get? You all get this, yes or no? So this over here is this term over here. Can you all get that? You did not get that. That's where I'm worried. You have to get that. You get it? You got it? Right? You got it? Okay. Good. Okay. So that's why I know it's just Eugene is just writing, flipping numbers and pressing calculator. Yeah. You have to press the calculator correctly. Are we clear? You all change to radian. You did, right? All these are in what? Remember, this term over here are all in what? Radians. You got it? You cheeky sort. Okay, so this will be equal to 198.944 or 945 times 10 to the power 6 Pascal. Okay. So for this case, why do we calculate that? So we calculate that because we know that our stress max is less than our what? Our stress yield. And we know that our stress yield is equal to what? 360 times 10 to the power 6 Pascal. Okay. And the last part of the question, okay, since all of you know how to calculate the secant now, I'm happy. We have to now determine our Y max. Okay, we have to determine our Y max. So the formula for Y max will be provided. So Y max is equal to E bracket secant square root of P over EI multiplied by L over 2. All these are within the secant, and then minus 1 square bracket. Okay, so I'll write this out. So this will be equal to 64.444 times 10 to the power minus 3. And then you have your secant, and then square root P is equal to 180 times 10 to the power 3. Young's modulus for this case is 200 times 10 to the power 9. And then your I is 6.9 times 10 to the power minus 6. And then you have to include your 4.2 divided by 2. You close your bracket and close another bracket, and then the whole thing minus by 1. Can someone compute this for me, please? What do you get? Okay, can some or all of you try to do that? What do you get? So this is equal to 64.444 times 10 to the power 3. I'm waiting for the answer. And I know at the end of the day, we have to minus 1. Anyone? Why am I asking that stupid question? Is it a stupid question? Oh, it's not. So this should be 1.378. And the deflection will be equal to what? 24.36 times 10 to the power minus 3 meters. Okay. Now, this is not that difficult, is it? Yes or no? Okay. It's just plugging in formula. But you need to know how to determine E, C, R squared, P, and your what? Your PCR. One question from your term test will be from eccentric loading. The other one will be from centric loading. And the third one will be on optimization. Are we clear? Okay, go home. No. Go to the next class. Don't go home. Sorry.